Lesson 6.2 is called Trigonometric Equations, Part 1. So we're going to solve relatively easier equation problems than section 6.3. And then we will see some examples that how we should handle trigonometric equations. We will not be able to model every single question on the homework, but we're going to give you good enough examples that you can apply to your homework problem. Our first question is, we want to solve 2 sine of theta plus 1 equals 0 over the interval 0 to 360 degree. 0 is included, but 360 is not included. To solve this trigonometric equation problem, we will take the given equation, and here we want to isolate sine of theta to look at what is the sine value that I need to focus, and I need to locate the angle. So subtract 1 from each side, and then divide each side by 2. So this equation will give me that sine of theta is equal to a negative 1/2. So this question is telling me that I want you to give me all the angles from 0 to 360 whose sine value is equal to a negative 1/2. Now, let's list some of the angles we know because of the unit circle. We know that sine of 30 is positive 1/2 because 30 is in quadrant 1 and sine values are positive in quadrant 1. Sine of 150 still refers to 30 degrees. This is the reference angle for 150. Its sine value is still positive 1/2 because sine is positive in quadrant 1 and quadrant 2 because sine means the y values and it's positive in both quadrants. When we move on to the third quadrant, 210 still uses the 30 degree as a reference angle, but in quadrant 3, sine value becomes negative. Again, the last angle in quadrant 4 is 330 degrees, still uses the 30 degree as reference angle, and the sine value is negative 1/2. So this is the fact that I know from the unit circle. If I go back to question, they only want the angles whose sine value is equal to negative 1/2, and the angles have to be between 0 to 360. So the expected answer is there's only 2 answers here, 210 degrees and 330 degrees. These are the only 2 angles in this interval whose sine value is equal to a negative 1/2. Now we're going to change this problem just a little bit. The equation will stay the same, but they're going to remove the interval. So the question is, we want you to still solve this equation, but not on a specific interval. Just give us the solution for all solutions, meaning that because sine is a periodic function, every time you finish a cycle around the unit circle, you start over. So the difference is now to find all solutions, we're going to add integer multiples of the period of the sine function. And remember, sine is periodic by 2 pi. Every 2 pi, sine repeats itself. So to each solution we found in part A, we're going to add the period of the sine function to find all the solutions. So when they remove the interval from the first problem, and they want us to locate the solutions for all solutions, one of the answers we got was 310, but plus 360 times n. Every time we repeat one period, we're going to find a new angle, comma, 330 plus 360 times n is an integer. This is how we're going to write the all solutions. This is our second example we're going to tackle. We want to solve sine theta times tangent of theta is equal to sine of theta over this interval from 0 to 360. So I have to do something to reduce it to one single trig function if it is possible. So this is how I am going to start. Sine of theta and tangent of theta is going to stay on the first side. And sine of theta is going to move to the other side as minus sine of theta, so that I can set the equation to 0. So I can factor the sine of theta from this equation. Sine of theta is a common factor, parentheses. So there is tangent of theta left here. So when I multiply them, the answer is sine theta times tangent theta minus, and then I have to multiply this by 1. So 1 times sine of theta is sine of theta, and this will be set to a 0. I am able to factor this, and then I know that when I am done with factoring, I can set each factor to this number. So sine of theta must be a 0 then, if the product is 0, or tangent of theta minus 1 must be set to 0. And then this one needs to go further, and then this will be getting the tangent of theta is 1. So this part of the equation asks me to find all the angles whose tangent value is equal to 1, and the interval that I need to consider is from 0 to 360 degrees. I know that tangent 45 is 1. In second quadrant, tangent values are negative, so I can't give them a second quadrant angle, but tangent is positive again in quadrant 3, and in quadrant 3, 225, tangent of 225 is still 1. So this part of the equation returns me two angles. But there is this part that I ignored for a while. I have to consider all the angles whose sine value is equal to 0, and this is the interval I have to consider. Angle 0, because sine 0 is 0, right? And then sine 90 is 1, but sine 180 is also equal to 0. So this part of the equation gives me two angles, and this part of the equation gives me two angles. So the solution set is this problem has four answers: 0, 45 degrees, 180 degrees, and 225 degrees. When theta becomes any of these values, this equation will work. That's what it means. For example 3, we have a quadratic equation. Whenever the question is in the form of quadratic equation, 95% of the times we're going to go through a factoring. So we want to solve tangent squared x plus 10x minus 2 equals to 0 over this interval. An interval is 0 to 2 pi, 0 is included, but 2 pi is not included. Since it's a quadratic equation, I'm going to try to factor this. And I can factor this as 10x plus 2 and 10x minus 1. How did I get this answer? Because I need two numbers. When I multiply them, their product is negative 2. When I add them, their sum is 1, and this is the correct factoring. When the factoring is done, and this equation is set to 0, we're going to set each factor to a 0. So tangent of x is equal to, actually, let's just take the whole factor, which is the first factor is 10x plus 2. I have to set this to a 0, and 10x minus 1 is set to a 0. And 10x will be equal to positive 1. So I have to think about all the angles whose tangent value is 1, and the interval I need to focus is from 0 to 2 pi. We know that for pi over 4, which represents 45 degrees, tangent 45 is equal to 1. So this is the one of the angles that I'm looking for. And tangent is positive again in quadrant 3. So in quadrant 3, 5 pi over 4 has the same tangent value, positive 1. So this part of the equation gives me two angles. When I isolate the 10x on the first side, 10x is equal to a negative 2. And this is not something actually I know by heart. I don't know the angles whose tangent value is equal to a negative 2. So I will have to use a calculator. So let's just go to decimals together. I am going to stop sharing for a second, and then I'm going to actually share the whole screen so we can actually also see the decimals. So here on decimals, I have two options. Remember, I am looking for the angle whose tangent value is equal to a negative 2. I can either just type the equation, 10x is equal to negative 2, and decimals gives me a graph. And because this question wants everything in radian mode, here I have to make sure that the mode is radian, and which was in radian. And then I have to focus to 0 to 2 pi. So 0, this is where it starts. 2 pi is little over than 6. So in this interval, tangent is equal to a negative 2 over here. Then when I hover over, it needs to work, but if it is not working and I need these two angles, I don't know, it's because I didn't log in, it doesn't give me the angle values when I click on it. So we can, if that doesn't work, I can tell the calculator that I need arc 10 of negative 2. And then it gives me that this will be the angle. But this angle doesn't fall into the interval of 0 to 2 pi, right? So I have to get the coterminal angle to this, which is adding 2 pi to this. If I add 2 pi to this, it gives me that this must be the angle I need in this interval, which is 5.1760. So 5.176. 5.176. When you see such question on my math app, you can see how you're going to combine these answers, whether they want it in pi or they want in degrees. You can think accordingly. So here the book says that for this part, they just got the same answer like we did, and then they added 2 pi to this, and then the book said that these are the two exact values for the first part of the equation. But then when they added 2 pi, I think we couldn't add the 2 pi here accordingly, because if arctan is this, we can just maybe copy this answer on the next line. So enter, Control V, and I will add 2 pi. It still gives me the same answer. So probably they made a mistake here, because when I did 2 pi, this is not what they get. They get this answer. So that's how we can solve this problem. Generally, when you are solving a trigonometric equation, you need to decide whether the equation is linear or in quadratic form so you can determine the solution method. If only one trigonometric function is present, first solve the equation for that function. If more than one trigonometric function is present, rearrange the equation so that one side equals to 0, then try to factor and set each factor equal to 0 and solve. If the equation is in quadratic form, but not factorable, use the quadratic formula. Check that solutions are in the desired interval. Try using the identities to change the form of the equation. It may be helpful to square each side first and check. This will be my final example to finish this video. And I got this example from the homework. We're going to solve this equation for exact solutions over the interval of 0 to 2 pi. And the question is 6 cosine squared x minus 12 cosine x plus 6 is equal to 0. Because this equation is in quadratic form, I know that I have to go through some factoring. And before I factor the trinomial, I realized that everything is a multiple of 6. So I want to put the 6 outside of the parentheses to make my factoring easier. So 6 is outside of the parentheses, and we get cosine squared x minus 2 cosine of x plus 1 is equal to 0. This allows me to divide each side by 6. So I can clear the 6 from the equation, and the equation becomes as simple as cosine squared x minus 2 cosine x plus 1, and 0 divided by 6 is just a 0. This quadratic equation now has to be factored to move to a linear form. So one factor will be cosine x minus 1, and the other factor will be cosine x minus 1, because -1 times -1 is +1, and when we add them up, their sum is a -2. So this will set to a 0, and it will give me cosine x to be 1. Since the same second part of the equation is going to give me the same thing, I don't have to work on this. So cosine of x is 1. So I have to think about all the angles whose cosine value is 1 on this interval. So cosine value means the x values. Cosine value is here 1, only here at 1, because here it's at -1. So the only angle whose cosine value is 1 on this interval is 0 degree, is the only accepted answer for this question. Good luck for the equations under 6.2 homework.